Firstly, can you hear me? Good afternoon, all. It's an honor to be here. I just want to talk to you briefly about who I am, what WAPA is, what we do, but more importantly, where we're going, because there's been some extremely dramatic changes. So, myself, I run and sit on the executive committee of WAPA, the Wireless Access Providers Association. We have plus minus 250 members, of which 200 plus are licensed, ICASA licensed service providers. We are a small organization. As you can see from this slide, that is the executive committee. They're all volunteers, apart from on the top line, Maddie, myself, and Leslie. You may notice that Leslie and myself share quite a unique common name. I promise you I didn't marry the CEO. That would have been too scary. It happened a long time before that. Anyway, marriage is scary enough with that. I mean, someone told me once, I was so scared when I got married, they said over 50% of marriages, last forever. So, what does WAPA do? We're basically an industry interface between our members, ICASA, the regulator, network operators, service providers. We submit to the government, we try and control regulation. There's a lot going on to achieve one thing, which is this: universal, meaningful connectivity. And this list sort of shows you what that is. And the biggest thing has been mentioned many times in this conference, and the minister was talking about it. Getting connectivity out there is one thing. Being affordable and access to everything. Affordability is everything. Now, the way the band of brothers, as I call them, the NTNs, the Vodacoms, Telcoms, they will quote you numbers on percentage covered in South Africa. Whether that's population or geographic, they're two different numbers. It's quite high, but it's not meaningful because it's not affordable. We're building networks out there, and this is happening on fiber, fixed wireless, and Wi-Fi hotspots on a 5 Rand per day model, 24 hours uncapped. That is affordable, okay? If you go on to MTN, what can you buy prepaid, or Vodacom, what can you buy prepaid for 5 Rand? The answer to that question is absolutely nothing, right? Their lowest entry-level package is 5 Rand 50, which will buy you a whole 38 megs of data. So that is the huge gap we're trying to address. So what are we doing? For a long time, I've been progressively chasing dynamic spectrum. And I'm going to explain what dynamic spectrum is just now. It's the key to everything in the wireless industry, not just in my operators, should be in the biggest operators. They don't like it, but it's reality. Dynamic spectrum, and we've had major breakthroughs. This is the biggest turning point in wireless history since we began to be able to do it after the famous court case with Altec Autopage against Telkom, where we were given the rights to deploy our own networks, and that's when the first ICNS license were issued. So, let me explain what dynamic spectrum is, okay? You see a glass jar full of stones. Imagine that was South Africa, was the jar. The stones are all on the same spectrum band, okay? The jar appears to be almost full up. Maybe there's a little bit of room on the top to put a few more stones, operators in that band. But is it truly full? What would happen if you started pouring fine grains of sand in that same jar? It would sink into all the holes, because there's many gaps in that jar between the stones. And that is what dynamic spectrum allocation is. You grant a spectrum for particular use. There are incumbent operators there. In the bands we're using, they're mostly fixed satellite service uplinks, but they're not using them everywhere. So within those gaps, if we use geolocation databases, automatic frequency coordination channel databases, we can exploit those gaps, which is exactly what we're doing. So TV Whitespace, I'll talk about now, was released in 2021 by ICASA. We've done much work on this. And what happened in that is we used the white spaces as the fuzzy bits between the TV channels. It's unused. So we delivered internet in TV whitespace spectrum without interfering with the TV radio stations. The lower 6 gigahertz band is about to be released for unlicensed use. At the moment, we are using probably 125 megahertz of spectrum in unlicensed Wi-Fi with hundreds of companies shouting for space. It's messy, it's noisy. If I'm in a football stadium that's empty and my mate's at the other end, if I shout loud enough, he can hear me. If I scream, he can hear me. Fill that stadium up with other people and the noise, he can't hear. That's what's happening in the reality of spectrum. That's about to be released, the 3.8 to 4.2. This is N77, this is private 5G I'm going to talk about. And the upper 6 gig, we'll get to that right at the end. So it started back. We did the first trials in Cape Town using white space and dynamic spectrum to prove a point. We did schools, universities. Tested 2012. We then moved over just later in the year to Limpopo, did the same thing. We were getting a feel now that we can operate in these empty dynamic spaces. Then everything went quiet until 2019, and this happened. I got a $1 million grant from US Trade and Development to do the first commercial white space trials in South Africa. And if you look at the photograph on the left, you'll see a CPE, a Wi-Fi access point, and what looks like a Yagi, it looks like a TV antenna. Of course it will look like a TV antenna. It's operating on the same spec as TV. And if you're seeing the picture, this is me wearing a tie, very unusual scenario. And also what's unusual about this photograph, you can see the American and the US flag crossing over on the front of the desk. Obviously, US and South Africa relations were a lot better in those days than they are today. Yeah. So I was a pioneer of diplomacy in those days. And we got an international team. There we all are, and we finished. It was difficult. This was 2019. Commercial trials, $1 million. Go for it, Paul. But something unforeseen happened. It was a virus called COVID-19 and 2 lockdowns. It's really hard to do commercial trials when everyone's locked down in their houses and can't travel, to get realistic results. So it went on for 3.5 years. Then suddenly we struck gold. This was released. A proposal just about to be released, along with the lower 6 gig, which is basically just more spectrum addition to 5.8. All the WISPs know how to do it. All my guys know how to do it. The top is N77 5G NR, new radio, standalone. It's real 5G to build private networks using dynamic spectrum. Real 5G. Has anyone ever been on a real 5G network? Because I assure you, we've got no 5G in South Africa, okay? The Vodacom and MTN's networks, they're LTE core with 5G radio strapped on the end. It's not fully functioning 5G, okay? That's what they call a non-standalone network. LTE core, 5G radio. If you're on 5G on your phone, you make a call or get a call, you'll see it drop back to LTE. Because 5G needs its own core to be able to carry voice and other media messaging services. We've got power. If you look, it's split into urban and rural. The power in urban is pretty pathetic, 27 dB. That's like half a watt of power, EIRP. Rural, we've got 47. That's 50 watts. We can go play nicely out there, and it's exactly what we did. So we started playing around, and we went through the regulations, how to build the database. Then we said, let's test it out, let's do field trials. So we did 2 sites in KZN, where we got 5G radio. We used CSIR's 5G standalone core, which is nothing more than a lab test bench core, really. It's not a commercial core, but it carries all the functionalities. And off we went to play in KZN for 2 days on these sites. These maps I'm showing you, all the points we took readings of on direct to handset, direct to external CPE, and direct to a 5G router on a coffee table. And we were getting results in near line of sight and non-line of sight, which is amazing because we can't do that in the normal fixed wireless Wi-Fi situation. Wi-Fi, we haven't got that sort of power. Wi-Fi hates trees. It hates building structure. What was it? It hates water. Yeah? Okay? It gets absorbed. It attenuates very quickly. And, even in this room where we got Wi-Fi, you guys are soaking up Wi-Fi. The Wi-Fi will be worse with you all in there as opposed to one of you. Why? Your bodies are 90% water. So you're saying, looking around, I can see some of you soaking up more Wi-Fi than the others. Yeah? So here it was. Here was the team. There's me standing next to Professor Dr. Lasangu from CSIR, who I worked with all through the whitespace trials. And here is the other slide, is the stakeholders. A mixture of CSIR and ICASA. You'll see that for some reason I was denied personal protection equipment, but the truth of the matter is I was the only one who had faith that the radio we put up was not going to fall on my head. Right? So what it looks like, there's the radio on a tower. The beauty of this, towers get congested, and you need what they call co-location space, because you don't want the radios to interfere with each other. Well, this is N77, 3.8 to 4.2, so you can stick it between all the other radios. It doesn't need the separation to build this. So what do we get out of it? Now, this is N77. This is in the 27 dBm. This is urban. Few hundred meters to a handset, 1 to 3 to 3B. It's not brilliant. We got to mark it and mess it around a bit. When we get out and we get more powerful, you see 1 to 5 kilometer range, which we tested in the trials. 2 handsets, 2 CPEs, and probably 5 to 15 if you get an external CPE. This is good stuff. It's expensive, needs a lot of design. Now, I'm going to tell you one of the beauties of it. I'll show you this slide first. The bucky in the back that you're looking at, we're all standing in front of, is an ICASA Spectrum truck. It's got more radio kit and analyzing gear than you've seen in your life. It's actually got reinforced suspension because that's the equipment weighs so much. But the most important piece of equipment in the back of the truck is on this slide. It's a spectrum analyzer, okay? And what it's showing is that squiggly bit, that's a 20 meg channel. That was our radio. The rest of it is showing thing. Look at the straight lines either side of that. There was nothing else out there. It's quiet. It's clean spectrum. Yeah? Absolutely clean spectrum. And that's what we want, no overcrowding. So what are we going to do with this spectrum? Okay? What are we going to do? What is the business case? 5G equipment is notoriously expensive. Yeah? Very expensive. To build a 5G core is complicated. Yeah? So we're going to build private networks. And I've done the research, and I want to tell you where I am and where we're going with this. In a rural application, community networks, it's too expensive. The unlicensed Wi-Fi model will rule every time with what we're using. I wish it wasn't like that, but it is. However, what I've been learning is what we can possibly do is what private 5G is brilliant for. Opencast mining, industrial manufacturing, agricultural, all these things. And surrounding these big places are normally villages or townships and everything that are supporting that of the workers who work at this place. Now, for an opencast mine, etc., you say, well, we're doing it with Wi-Fi. Yes, we are at the moment. It's problematic, especially as you get deeper, because the Wi-Fi ones don't want to go down the hole, right? So you can put your radios down the hole as well, but every time you start using explosives, you've got a problem of blowing your radios out the bottom of the cast. 5G is better for that, to keep it out, and it's got to be critical with zero interference from everything else. You don't want an autonomous mining vehicle, which is 100 tons of yellow metal coming towards you, that it's lost contact with its connectivity and is going for a walk on its own. So, it's very mission critical stuff. And these are the guys who want to spend big money on this. They want to spend big money. The reason being, I've looked at global calculations on mining. Just a few hours of lost production can cost them hundreds of thousands of dollars. So they want to protect themselves with that. So I'm designing models around agricultural, industrial manufacturing, forestry, opencast mining, to use it as an anchor tenant model, where, like, imagine a shopping mall. For a shopping mall to be successful and get lots of small shops, like small little communities in an area, what do you need? Anchor tenants. You need a Pick and Pay, you need a Woolies, you need a Checkers. You need the banks. Those are your anchor tenants, and you use that as the lever to get the small guys. That's exactly what I'm building now and designing, okay? So you get a couple of anchor tenants on these networks, big guys, who are paying the big bucks. And the great thing about standalone 5G that you can't do on the toy 5G that we got here is something called network slicing. You can cut the network into pieces. So we're talking dedicated, unlike a normal mobile network that's floating up and down depending on the usage and all this. Latency's changing, upload speed, download. You've all seen it 1,000 times. So we can slice the network and guarantee dedicated super low latency with that fluctuation to the anchor clients, and then use the rest for the surrounding communities. Similar to the CBRS model they used in the US, which is private LTE operating in 3.5 gigahertz, okay? And that's running very well, and it works on a tiered level, like a pyramid. At the top, do not touch. maritime, reserved. Same spectrum. The middle section, priority. Pay and you get good service. Then right at the bottom is like a basic free-for-all. Like we've got in Wi-Fi and cellular at the moment, is what we're experiencing, you know. Switch on your phone and take your chance, huh? You know? I mean, cell signal is so bad in this country, you can make your own party game by saying, right, choose a spot in the house, all right, and do a speed test, and the one who gets the best speed wins the prize. Because that's how varying it is. It's completely crazy. So that's a very brief introduction. It's coming. I've said to ICASA, I said this thing, that this happened quite quickly on this 14-year journey of dynamic spectrum. The recent bit's only been a couple of years. I told them, it is the single biggest, most wonderful thing ICASA has ever done in its history, is what they've done here, okay? There's no question. And it is the biggest thing for my WISPs and anyone in a wireless provider to suddenly have this spectrum. To go from 125 megs that are all piled in on everyone, not just WISPs, everyone, CCVD suppliers are all using that band. It's a mess. All right? To go from 125, here's another 500, clean. Okay, it's huge. Oh, by the way, how about some 5G spectrum? Another 400 megahertz. Clean. Let's use it. Let's go build with it. But it gets better because there's also, up for grabs, the upper 6 gigahertz bands, the 6,425 to 7.125. Now, that has been open for unlicensed Wi-Fi in the States, Canada, various other countries across the world. It's working, it's brilliant. So if you open both blocks, that's 1.2 gigahertz of contiguous spectrum in unlicensed, okay? Now, the upper 6 big band, there's a fight on, because shall we give it to IMT for the cellular guys? We give it to Paul for his WISPs and unlicensed use. IMT won't work. They cannot protect the incumbents of full power. We all know current 5G operates on 3.5, okay? And it's got crappy building and house penetration. We all know this, right? That's why our 5G routers, we're moving around the house and we're trying at every window to try and get a few bars out of it. It's not good at penetration. Now, the higher the frequency, the worse the penetration gets. So if you think 3.5 is bad, and they want to go upper 6 and lower 7, it will actually be an additional 6 dB loss. So it's going to be a hell of a lot worse. Plus, they're going to have less power. It's going to be a crisis. Yeah? So, why do they want it? Why do they want it? One of the thinking is, and I don't think anyone does, the first auction that went was in Hong Kong. They only hit reserve price and 25% of the lots weren't sold. And the previous Hong Kong auction with the other spectrum, the lots hit 6 to 7 times above reserve. It shows disinterested, that they're not actually, maybe they want to buy it to keep it away from us. Because given that spectrum, we'll give them a run from their fixed wireless for money. So those are the next challenges. Oh, sorry. And this is the big fight. You see, we got ICASA in the middle as the referee. We got Vodacom, MTN, and all the rest of the band of brothers, and there's me on the other side having this giant fight. And that's why I urge you, all of you, because this is beneficial not just to wireless providers, anybody. If you're doing fiber, you're doing something else. Everything's wireless. Even if you deliver fiber, you're putting wireless on the end of it. You're putting unlicensed Wi-Fi on it. You know, I haven't seen a cell phone yet with an Ethernet port or an FSP. It doesn't happen. So join us in that fight, because I'm taking it. That's my next fight. I think there should be a few questions. I'd say it's the biggest thing that's happened in the industry. It's magical for me. We're busy building the cores, designing them, testing them. By the end of the year, we should have something concrete. And no longer are we playing second fiddle. We can deliver speeds in wireless that you can do on fiber. We can do better quality fixed wireless than the mobile operators, because their fixed wireless is up and down like everything. You get a traffic jam outside or a roadblock outside your house, everyone gets on their phones and your signal inside your house collapses. It's ridiculous. So join in that fight. And I'm going to take some quick questions from anyone, because it's a very detailed subject. It's brand new. It's been done virtually nowhere in the world. I'm the first one who's starting to play with it, so that's exciting. The only good thing about it is, because I probably don't know what I'm doing, there's no one out there to tell me that I'm getting it wrong. So, thank you guys.
Hi there. Hopefully not a difficult question, but I'm Ed from Internet.
I know.
Everyone else doesn't. You said it's very expensive for these things to be rolled out, your little 5G areas for, a 5G base station for this type of a setup.
Yeah.
How expensive are we speaking? Is it?
Okay, good. Very good question. I've started looking at equipment. I can't tell you what I'm going to use. I know what we used in the trials. That was a 90-degree sector radio, cost $8,000. Okay? I made a long list of everyone who produces equipment in the N77 band. All right? I haven't made a decision, but I can tell you I've started crossing people off that list. They are Huawei, Ericsson, Nokia, ZTE. Those radios are going between $15,000 and $30,000 a piece. It blows it out the water. I want a 5G sector radio. I would like it smaller, but $5,000 or less, right? The problem here lies is not in the radios themselves. Then, of course, these handsets, only Galaxy S21s and above, the A34, support N77, so there's no cheap entry-level handset. And you've got to SIM provision. You've got to program your own SIMs. You all think SIM cards are cheap because you see them in Pick and Pay for £1, or they give them to you for free. Programmable SIMs are not cheap. They're very expensive. So they say, Paul, go eSIM. eSIM's even more expensive from a compliance perspective and building the core. eSIM probably won't work unless you get probably up to sort of 500,000 subscribers plus. Plus a lot of the routers we're putting down and CPEs won't support eSIM anyway. Okay? So those are your costing, the provision of the SIM, the radio hardware, CPEs, the routers we got on. So at the moment we got desktop 5G router, $3,000, $2,000. Price is coming down. We're getting there that side. The radio's still a bit of an issue. The problem is the core. Now, what the big boys, they say they provide their own core for you and their own licensing, and it's the licensing that blows it out the water. It's insanely expensive. In fact, if you're building a multi-million and 5G network, probably 35% of the cost will be the core, the actual 5G core itself, not hardware, right? And the licensing of it. And of course, it's all proprietary. So the systems that I'm designing and building, I'm now looking at what we call Open RAN, Open Radio Access Networks. I want to go to a guy, does your radio, is it software defined? Is it Open RAN, yes or no? If they say it is, I want to buy it from you and walk away with it. Don't talk to me about licenses, don't talk to me about ongoing stuff like that. You can't use the same model the cellular guys did. Yeah? So once we get it down to maybe $5,000. One of my dreams is $4,000 for radio. Only rebate. But the core, I can build open source, Linux. If I've got 5 years and stretch my brain. Look, there's a lot of hardware. You run it on x86 servers and you do it. It's incredibly complex, the layers of 5G standalone, as opposed to conventional Wi-Fi networks. But it can be done, and it's exactly what I'm doing now. Because it's one thing to prove what we did, it can be done and it works and we can take it out there. Now it's got to have a business case that people will build it because it's got to have a realistic ROI. That's it. That's what I'm building now. So I have to say, all the proprietary stuff's out the window, all the licensing of proprietary cores are out the window, and also there's not much out there anyway, because I said no one's done it before. I'm sort of pioneering the waves out there. So to answer your question, expensive, horribly. Anything else?
Yes, thank you, Paul.
Are we done?
You are.
Sorry, I am. I hate to inform you, I was a long time ago.
I have something for you. Yeah. A little gift from the.
Oh, thank you.